Hello and welcome to the second part of our GlassFish 4 webinar series. My name is Shani Anup from C2B2, and in this edition of the webinar series we'll discuss the features for a high availability. So we're going to look into GlassFish 4 and what it can do for clustering, load balancing, session replication, and we're also going to do a few demonstrations on how to configure that within GlassFish 4. So in the first edition of the webinar series, we discussed how to get started with GlassFish and how to install it, how to deploy it, etc. In this one, we're going to discuss the high availability features. There will be another webinar series on monitoring, and the final one will be on migrating to GlassFish, what you need to do when you have an existing application and you want to migrate it to the GlassFish application server. So what are we going to discuss today in detail? So at first, an introduction into high availability in general, on what we think is high availability. We'll start with discussing the three most important features of GlassFish for high availabilities. There will be load balancing, clustering, and session replications. There are other features which I will briefly highlight, but cannot discuss in more detail, which I will discuss at the end. So starting with high availability in general. With high availability, you usually mean that we have a system and it's serving clients, or it's processing something, and you want to have as minimal downtime as possible. So if there's a system failure, you want to have another system that can take over. So there should be some level of redundancy that can implement the failover part. So to avoid getting into that situation where you have a system failure, it is wise to avoid, or a better word is prevent, resource contention. So it's a good idea to spread out your system over multiple servers, multiple instances of the same application server, and to have some way of load balancing between those. So if you have the redundancy and the failover, and you have a method to load balance across multiple instances of your system, those are good starting points to get a highly available system. So if you're looking at GlassFish specifically, what does it have in store for creating a high available system in your environment where you have an application running on GlassFish? So one of the things you can do is instance clustering. So creating a unit of multiple GlassFish instances and administering them, deploying application then as a single unit. The second thing is session replication, which allows you to have that failover part. I will discuss this in detail later on. And another big part of the HA features are the JMS clustering features that are in GlassFish. So that is pretty extensive, but I will not discuss that part, the JMS part, in this webinar. So I'll focus on the clustering, replication, load balancing part. So now with the recent release of GlassFish 4, what has changed? So the most important part of version 4.0 is Java EE7 compliance. So getting all those new features, all the new JSRs that are part of EE7, to get it in there and working as good as possible. Clustering was already there in 3.1, and it is still there in 4.0, but Oracle's not really publicizing that. They're calling it early access, so all the clustering is there, but they basically put in a disclaimer saying, okay, it's not fully tested, and it will be fully tested and released with 4.1. which is scheduled somewhere next year in 2014. So if you have a production environment that you want to run GlassFish on, you have two options: either resort to the previous version 3.1 or use 4.0, but use a different way to get the same kind of HA features using external tooling. So I will come back to that later on, where we will see how to use a data grid for your session replication across multiple instances without using the clustering feature. So talking about the roadmap of GlassFish 4, so as I said, next year, somewhere in 2014, they will release the 4.1, which has the clustering fully tested and fully available. But of course, you can already test it. It seems to be working fine, but you might have hit some problems or bugs when deploying your application on a clustered GlassFish 4. So it would be a good idea to submit a bug report. It's an open source project, so that would be even better for you. So you can make sure that those bugs are resolved when 4.1 comes out, for sure. So GlassFish 4.1 also is, I think, tied with Oracle GlassFish Server, which is a commercial edition and that offers a little bit more of the features that you might use in the HA system. For now, we'll look at GlassFish 4.0 and see what we can do with that. So first of all, what I would like to start with is load balancing. So as I said, you can spread the number of requests that come in over different GlassFish instances. So in this case, you don't even need to have the GlassFish clustering. You can just have standalone GlassFish instances. Each of those will have your application deployed on it, and typically you will have an Apache server or another server. In this case, we'll focus on Apache, that will load balance across the different GlassFish instances. And it is a good idea to have sticky session enabled, so the first app server that handles the request from a user, or let's say from a client or a browser, or a different system calling that service, to have the Apache load balancer route subsequent requests to that same instance. So you will minimize any time to switch between the different instances. So what are the options for Apache as a load balancer for GlassFish? So there are two different protocols that you can use. You can use simple HTTP load balancing. So GlassFish, you will have your web app deployed on there, and that can accept HTTP requests. So you'll have your Apache forwarding, basically, and forwarding HTTP requests to multiple instances of GlassFish. So another thing that GlassFish can do is it supports the AJP protocol, which you can use in combination with mod JK, because the Tomcat connector, which enables the AJP protocol, which is slightly more efficient than plain HTTP. It's a binary protocol, and it's better optimized to connect to Java app servers. So, for example, Tomcat standalone supports that, and the Apache model that is distributed by Tomcat can be installed into Apache, which is mod JK, which is pretty advanced and complex load balancing module, I would say. So there's another option if you want to have that AJP protocol, which is mod proxy, which is bundled with Apache 2.2. So if you have Apache 2.2, you will already have a mod proxy. So that is a bit simpler than mod JK, but also less powerful. So how to configure this? You need to change your Apache configuration. So this is an example for mode proxy balancing, because this is the simplest solution and it's bundled with Apache. So what you do is you create a proxy path, which basically says, okay, everything that comes in from this context root, so the AJP part, or in the lower one it's the slash, use the proxy balancer. So the proxy balancer is defined in the proxy tag, and there you just list the different kinds of the different instances that you want to route to, that you want to load balance on. And with just say prefixing it with AJP or HTTP, you decide which protocol to use, basically for load balancing. So there isn't a lot of configuration required. So after this, add it to Apache, restart it, and it will start load balancing. So I will show this later on in the demonstration. So as said, no clustering required, so you don't have to rely on the possibly buggy clustering features of GlassFish 4. So you can load balance across multiple standalones. There's one thing to remember when you want to use the mod JK or the AJP load balancing from a proxy, that you need to explicitly enable a JK Listener. So you can do that in the admin console. You can also do it from the command line. Again, I will show you this later on in the demonstration, but here you can see a screenshot of where it is. There, you do it in the server configuration, or if your cluster, you can do it in the cluster configuration. I will discuss this later on again. So the real fun is in GlassFish clustering, because there, you have the actual HA availability features. As most important is the session replication. So the session replication will allow you to have failover without your clients noticing it. So a client might be interacting with one of the app servers, and the web application might be storing data into it, but it will replicate it across all of the instances in a cluster. So if it goes down, the load balancer will switch to the second one or the third one or whatever, and the client won't even notice, because it is interacting with Apache in front of it, which load balances it. The other thing that clustering offers, it's easier configuration. You can use one domain administration server and manage multiple instances as a single unit. If you change the configuration for one of those, it will be propagated to all the others. The same is with deployment. If you have an application you want to have deployed over multiple instances targeted to a cluster, it will be deployed on all of the different JVMs that has GlassFish running on it, and it doesn't even matter whether it's on the same machine or different machines. So big advantages there for clustering. So in a diagram form, so what are the different components? So you have the cluster, you have a domain administration server, which does the configuration part and the deployment part. Then you'll have actual nodes. So with nodes in GlassFish terminology, those are machines or Linux servers or Windows servers. It could be a VM, but it's an operating system where GlassFish is installed. And on that node, you can have multiple JVMs that have GlassFish running on it, and those are the GlassFish instances. So the domain administration server communicates through SSH or DCOM if it's Windows to provide the configuration commands, basically. And the group management service is used to just for communication between the different GlassFish instances, so for replicating the session data or for notifying failures. So you have three components here. You have the admin server, the DAS, you have the node, which the machine runs on, and you have the GlassFish instance itself, which will do the actual hard work. So the cluster nodes with the machines, those have GlassFish installed, and there are different types of cluster nodes. So if you want to have one which is local, without any remote communication or network communication, you can create a config node. There's a DCOM option if you have a remote Windows server, and there's SSH, which you can use for a remote Linux server or a Windows server with an SSH daemon installed on it. Again, from the admin console, you can create new nodes. So that's one of the first steps that you need to do if you want to create a cluster that has instances spread over multiple machines. So you need to tell the admin server, okay, there's a new machine. This is how you are going to communicate with it. It's going to be SSH, DCOM. This is where this is the host name, etc. And then you can add instances to it, create a cluster and assign where you want to run every instance. So I can quickly demonstrate that. It's nice to have a bit of demonstration. Okay, so here what I did, I created a new domain in GlassFish, called it webinar domain. See, this here, and it doesn't have a cluster. It's just a single admin server that is running. There are no applications deployed, and the only thing I changed here is the memory assigned to it, to the JVM. So looking at the nodes, so initially there will only be one node, which is the node that the admin server is running on. So we can create a new one. I don't have a remote server right now. I'm gonna create a cluster locally, so I don't need to create one here, but I'll show you the options. You have the DCOM config, and there's a really nice option that can install GlassFish server on that node. So you have another machine, another VM running, and if you configure the SSH, give the right username and make sure it has the right permissions now to write to the installation directory, then you can have this enabled, and on creation it will actually put the zip file over on the new machine and basically install GlassFish on it. So that's pretty cool stuff. The cluster configuration is done here. So of course in the cluster screen there are a few steps involved, but it's very easy. Going to create a new cluster and call it cluster 1. You can select which configuration you want. There's only one configuration right now to choose from, and that will be copied as mentioned. Or you can reference it, so if you update the original one, it will be propagated to the others that are linked to it. So I'm going to create a 2-instance cluster. So instance 1, and there's only one node to select from, so I'll just give it to the same node, and instance 2, and that's it. You have your cluster. Once it's finished, there's a cluster created. By default it is not started yet, so you can see here there's a cluster, create cluster 1 as cluster config. That will be visible in the configuration screen, where you can see the cluster config. So if you change anything here, for example, in this case I will go to the HTTP servers, and I want to have a new HTTP listener, because right now we only have the 2 HTTP listener. One is for normal HTTP and one is for SSL. And if you want to create a new one, you can create it here, and all of the instances will have that same listener. So the reason I've gone into this screen is this is where you can see you can enable the JK Listener. So if you want to use the more efficient HTTP protocol, you have to create a new listener and enable this. So this will stop the server from listening on that same port to normal HTTP request. So that's the reason I'm saying you need to create another listener. So you have the option of going to normal HTTP or having only the JK on a different port. So this is the way you do that. I'm not gonna do it right now. I'm just gonna use normal HTTP. So back to the cluster. It's still stopped, but I want to have it running. So now it will start 2 new JVMs on the same machine with that same configuration, and then we can start deploying let's say extra applications on it. So for how do the instances communicate between each other? And there's this thing called the group management service, and GlassFish will they like to call it in the service. So the group management service is basically the protocol that is used to communicate between the different instances. So they'll have heartbeat, session replication going over there. If there are global transactions going on, they will replicate that data. And by default, it's using multicast for that. You can switch it to TCP without multicast. To do that, you can do that from the admin console itself. We're not going into detail on that. We'll just stick with the default UDP multicast, which is the easiest to set up because it's basically auto discovery. Because they're all listening to the same multicast address. So there is a tool. Sometimes you have network problems. For instance, when configuring the machine, I saw that IP tables was blocking any multicast communication by default. So there is a tool in the AS admin that you can use to validate whether the multicast run. So you can see that it is running, the 2 instances. And I'll show you the AS admin validate multicast tool. So it just sends a message to the multicast address. Right now nobody is listening, so we're going to change that. I'm going to do another one. Hopefully I'm just in time until it times out. So it says back to this one, receive data from localhost. So this doesn't really make sense because it's on the same machine, so of course it will work, you would think, but I had the IP tables problem, so it didn't even work locally. But normally you would do that on a different machine, on a different server, and run one validate multicast there. Then you go SH to the other server and do it there, and then you can easily see where it can communicate over multicast, over UDP multicast with each other. Anything else I want to show? Yeah, so you have the 2 instances, and when you click on one of the instances, you can see the different properties. So each of the instances will have properties defined, and the most important ones are the ports that it is listening on. So this one is listening on 280.81, and the other one will be listening to 280.82 or 80. So GlassFish checks which ports are available. So if you have a cluster already running, it will see, okay, the port is already used, and it will just use the next one. And it has kind of a pattern for different types of ports. It's pretty easy to create a cluster. Okay. So configuring a cluster. So as I showed you, can be done through the admin console pretty easily. And on the command line, if you want to script the building of your environment, you can do it with AS admin commands using the create cluster option, telling it which configuration, which multicast address, etc. So the session replication is one of, it's usually the reason people are creating a cluster. So what does it do? In your Java web application, you can store data in the HTTP session object, and with session replication, it will be spread out over all of the instances within the cluster. So one goes down, doesn't matter, because the other instances know that this session ID will have this data associated with it. So if you have an Apache load balancer in front of it, the client won't even know that something happened. And that's what you want in a HA environment. Again here, I recommend using sticky sessions. So initially you will go to the same instance over and over again, but if it crashes, only then you will switch. So what do you need? You need to have a cluster, of course. So start with a node, create a cluster, assign instances to it, validate that multicast is working. Second, change the web app. If the distribute tag is in the web.xml, it will be eligible for session replication. Otherwise, it won't work. Number 3 is by default enabled. Just wise to check it. If you see it doesn't work, there is an option called availability service, and it should be enabled. Otherwise, session replication won't work. The last step is that you should deploy the web app, and this is not enabled by default, but you should check the availability checkbox when deploying the application to make sure that it will use the session replication features. So let's do that. Let's have a application deployed on the cluster. So we're going to the admin console, go to the cluster, it's a simple deploy, and we have one ER file, and the ER file is a test application, so that you can easily check your session replication features. So here's the most important part: availability should be checked. If you do that, it will be replicating the session. Second thing is the targets. Here we're not targeting a single server. There's only an admin server and a cluster. So we're just saying, okay, deploy it on this server, and it will distribute the file across the different instances and deploy it. And in this case, it will also have session replication enabled. So just a quick idea of the code. It's basically a simple JSP file, an HA JSP sample, which prints out a bunch of stuff that it gets from the request, so you know which host we are currently talking to and which session ID it is. And there is this simple form, and in the form you can add data to the session, which will be stored here in a very standard manner. Let's see if it is deployed already. Oh, it is already deployed. So we open the properties file, properties screen for that application. Here we can see the JSP that I'm talking about, that I just showed you. Go into the launch, into the launch screen. What the launch screen will show you are all of the different URLs that it is deployed to. So we have two instances, instance 2 and instance 1, and both of those have two HTTP listeners, one for normal HTTP and one for HTTPS. So we have this port 28081. So there's this one, and here we have the server port number, so we know it's that instance, and we're going to add some data saying, okay, this is the name C2B2, put that in the session. So now it's in the session on that instance. But of course we want to see when we go to the other one, the other instance with the same session ID, whether the data will be there. So the page is loaded from the second instance, so it's a different URL. Server port number is 80 instead of 81 at the end, and it still retrieved data from the session saying, okay, the name is C2B2, and the message is hello. Just some stupid data, and when we go back to the other instance, it will have the same data. So it's not a very complex application, but it does demonstrate that it works. Now I can show you the Apache configuration. That's all right. This is what you saw in the screenshot. There are two proxies. Proxy is defined. One reroutes everything from slash, or everything from localhost slash to this proxy balancer, which is a normal HTTP load balancing, going to that 280.80 and 81 at the end. So if you go to localhost port 80, it should load balance across the two different instances. So here you see the actual JSP is being served by 280.81, but the user doesn't see anything. He just sees the normal HTTP port. If we reload it, it goes to 80, again 80, 81, 80, 81, 80. So it continuously load balances between the two of those. If you do too often, then Firefox thinks, yeah, I'm going to create a new session for that. Let's see if this still works. Add new session, reload page, goes to another one, but the data is still there. So the client doesn't notice that you're actually being served by different application servers, and data is persistent. So that is what you want. So that's one thing I didn't show, and that was the availability service that I mentioned. This is the cluster config, and here's the availability service, and this should be enabled in order to have the replication part working. So it has it on different level. You have availability server at the cluster. You can also have enable or disable it specifically for the web apps, for the HTTP apps, JMS, and in this case there are a few options that you can configure here. Okay. So there's another option, because there are some limitations to the in-memory session replication, because that is what GlassFish does, keeps it all in memory and uses a group management service to communicate to the different instances. You are limited to the memory that the GlassFish instances have. So if each one has 2 gigabytes or 4 gigabytes or whatever, you can only store that much session data in your cluster. So if you have a lot of users, or if bursts of users coming in and storing a lot of data, that might overload your GlassFish instance. You might not have enough memory, resulting in failures, garbage collection issues, or other nasty things which you don't want. So there is an alternative that I want to discuss, that is data grid. Use a data grid for session replication can be a lot more scalable. So in the data grid, show you a picture. What you can do with a data grid is you have multiple servers for a data grid, multiple instances, and the data will be stored in those instances and not on the GlassFish, not in the memory of the GlassFish. So when you add a new instance to the data grid, typically what they will do is they will distribute the data so the new instance knows everything about the rest. So you can elastically increase the storage size and have the replication of state and the replication of anything you want to have for your users to have that replicated in a scalable manner. So multiple options for that. So you can look at coherence. If you have the commercial version of GlassFish, the Oracle GlassFish server, then there is a coherence web extension that you can use to plug your sessions into a coherence cluster. There's the InfiniSpan, which is an open source data grid that's being developed by Red Hat, and there's another popular one is Gemfire. So there are multiple options, and in this case you don't have to rely on the clustering part. So again, if you're not very confident about the GlassFish clustering in 4, you can use this external data grid, and it will even give you, even better scalability with that, and keep your GlassFish instances standalone. Other HA features that I didn't discuss yet, but GlassFish offers, they have extensive support for JMS clustering, and it's very well documented in the HA administration guide of GlassFish. They have many different topologies that they support for client failover, but also handling server crashes or doing the load balancing. Another feature related to HA is application upgrades. So if you want to replace your application with a new version and without downtime, that is possible. And the last thing that I want to mention is the HAB load balancing, because that is totally separate from the HTTP load balancing. And this is if you have enterprise Java beans deployed and you want to have the communication over RMI, load balancing would fail over. So I would say this brings us to the end of the webinar, and I will point you to a few of the links that might be useful for you. So we have a blog for C2B2 where we regularly post GlassFish 4 or just GlassFish articles, but also articles on different Java middleware. Each of the webinars on GlassFish will have an accompanying blog post with it. You can watch the other videos. There will be links to all of the videos of all of the webinars that will be put on YouTube. And I would also like to tell you about the GlassFish use group that we're organizing, which offers regular presentations. We organize events where we have speakers coming in with a lot of experience, sharing their experience on GlassFish with the rest of the user group. So make sure to sign up for the user group. I would like to thank you for your attention, and hopefully you'll join one of the next webinars.